Hey there, fellow skygazers. Have you ever wondered why the sky looks blue during the day, and sometimes even turns pink or orange during sunrise or sunset? Well, buckle up because we're about to take a deep dive into the science behind these breathtaking sky colors. First things first, let's tackle the big question. Why does the sky appear blue during the day? Well, the answer lies in a phenomenon called Rayleigh scattering. Imagine this. Sunlight is made up of a spectrum of colors, from red to violet. These colors have different wavelengths, with red having the longest wavelength and violet the shortest. Now, when sunlight enters Earth's atmosphere, it encounters tiny molecules like nitrogen and oxygen. These molecules are much smaller than the wavelength of visible light, so they scatter sunlight in all directions. But here's the kicker: shorter wavelengths, like violet and blue, are scattered more effectively than longer wavelengths, like red and yellow. So, during the day, when the sun is high in the sky, sunlight passes through a thicker layer of atmosphere. The shorter blue wavelengths get scattered in all directions by the molecules in the atmosphere, giving the sky its iconic blue color. Meanwhile, the longer wavelengths like red and yellow continue on a straighter path, which is why we see the sun as yellowish-white. But wait, there's more. As the sun starts to set or rise, something magical happens. The sunlight has to travel through a thicker layer of atmosphere at a lower angle, especially during sunrise or sunset. This means that the shorter blue wavelengths get scattered out even more, leaving behind the longer wavelengths like red, orange, and pink to dominate the sky. Ever noticed how the sky can turn a mesmerizing shade of pink or orange during sunrise or sunset? That's because the longer wavelengths of light, particularly red and orange, are able to travel a longer path through the atmosphere and reach our eyes more prominently. But it's not just Rayleigh scattering that contributes to these colorful displays. Another player in the game is Mie scattering, which involves larger particles like dust, water droplets, and pollutants in the atmosphere. These larger particles scatter light of all wavelengths more equally, creating a diffuse glow during sunrise and sunset, and adding to the palette of colors we see. Now, let's talk about why the sky isn't always blue. Have you ever noticed that the sky can appear different shades of blue throughout the day? This variation in sky color is influenced by factors like the angle of the sun, the amount of moisture and particles in the atmosphere, and even the time of year. During midday, when the sun is directly overhead, the sky tends to appear a deep, intense blue. This is because the sunlight is passing through the least amount of atmosphere, and the shorter blue wavelengths are scattered more effectively. As the sun starts to lower in the sky towards evening, the light has to pass through a thicker layer of atmosphere. This can scatter more of the blue light, making the sky appear paler or even whitish near the horizon. In addition to Rayleigh scattering, which is more pronounced for shorter wavelengths, there's also a phenomenon called the Tyndall effect. This effect is responsible for the blue color of the sky when you look directly at the sun, like during a solar eclipse. It's caused by the scattering of sunlight by particles in the atmosphere, regardless of their size. Now let's circle back to those stunning pink and orange skies. The vibrant hues we see during sunrise and sunset are not just about scattering. They also involve a process called atmospheric refraction. This is when sunlight is bent or refracted as it passes through the Earth's atmosphere, especially when the sun is near the horizon. During sunrise and sunset, the sunlight has to travel through a thicker layer of atmosphere at a shallow angle. This causes the longer wavelengths, like red and orange, to be refracted or bent more than the shorter wavelengths. As a result, these warm colors are scattered across the sky, painting it in those gorgeous hues. But wait, there's one more twist to the story. Have you ever seen a sky that's not just blue or pink, but a mix of colors like purple or green? These rare occurrences can happen due to a combination of factors like specific atmospheric conditions, the presence of certain particles or pollutants, and even optical illusions. For example, a purple sky might occur when there's a high concentration of dust or pollutants in the atmosphere that scatter light in a way that combines blue and red wavelengths, creating a purplish tint. As for green skies, they can sometimes be observed before a thunderstorm. This greenish hue is believed to result from a combination of sunlight filtering through storm clouds and the scattering of light by water droplets or ice crystals in the atmosphere. So, there you have it, the fascinating science behind why the sky appears blue during the day and can turn into a spectacular canvas of colors during sunrise and sunset. From Rayleigh scattering to atmospheric refraction, there's a whole world of physics and optics at play every time we gaze up at the sky. Next time you find yourself marveling at a sunset or staring up at a blue sky, remember the intricate dance of light, molecules, and particles that creates these stunning visual displays. And keep looking up, because you never know what captivating sky colors await.